Welcome, and thank you for joining me on this session about incident response in cloud. The aim of the session is to give you tools and knowledge to be able to efficiently handle incident response in a cloud and to make you successful in this activity. I plan to cover some of the challenges associated with cloud incident response versus how they are happening in the traditional on-prem environment. I will plan to cover a couple of the fun new cloud tools and acronyms associated with these activities, which can help you on your journey. I plan to cover the importance of cloud logging and getting data into different platforms, cover some of the aspects of using the existing incident response frameworks and transferring them into cloud incident response, touch on the importance of SIEM and SOAR, have a couple of words about testing your cloud incident response plan, and cover a couple of thoughts about how artificial intelligence can help and augment your cloud incident response. The session will be finished off with a couple of best practices shared with the audience. Just a couple of words about myself before I jump in the middle of it. My name is Andres. I came here from the nice and sunny, rainy UK. I had a fairly varied career path over the last 20 plus years, working with a couple of big brands from Cisco to Hewlett-Packard, JP Morgan Chase, Mandiant, and Google Cloud. This gave me a fairly good visibility and understanding in lots of different ways how different companies and infrastructures can handle incident response in different environments. Just a bit of a non-IT specific fact about me. I used to play competitive basketball before I turned to IT. I used to be able to slam dunk as well. Those days are sadly gone, although I do believe my knees potentially prefer me defending the cloud and defying gravity from behind the keyboard instead of the basketball courts. I love spending my time with my family, my wife, 3 children, 1 dog and a cat, and I still like to play some squash, basketball, and some video games when my time permits. It's enough about me. Let's dive into today's topic. What is Cloudpocalypse? When I first came up with the idea about this talk, I was struggling to show what I meant by Cloudpocalypse. So I done what lots of us do nowadays and turned to AI. And let's say what AI thinks if he hear the words Cloudpocalypse. And the results are there. It's a bit of a scary picture. It's not something I would really like my infrastructure and environment to look like, and I really would like to avoid being caught out in a storm like this. And I'm sure that you would like to avoid being in the same yourself. So let's have a look at ways how we can tackle and make sure we can weather any storm coming our way. First, I wanted to look at some of the challenges which can be faced within cloud for incident response. There's a massive difference between on-prem and cloud, and this is mainly down to the amount of visibility and control we have on our infrastructure due to the shared responsibility model, which can differ on the amount of control you have depending on what kind of access you have from platform to infrastructure to software as a service. Because of this, we do have a high reliance on the provider security. We have to make sure that the one we pick, we trust what they say they do, but that doesn't stop us trying to still test some of this ourselves, which we will talk about at a later part of the presentation. It is really difficult to collect data, and the data collection and ingestion for logs can be difficult because sometimes you may not have access to the logs and data you need because they stay on the cloud part. But even when you do have access to it, it can be challenging trying to get the amount of data into your platform. The environments in cloud are changing rapidly. New features are coming out almost every day, and even us cloud computing experts, finding it hard sometimes to keep up with the latest technologies, which is also resulting still having a bit of a cloud expertise issues, because it's difficult to keep up with the trend and the amount of resources available. The surface where we include with our infrastructure is massive. It can cover multiple regions because we are deploying services not just in a single location, but cloud is covering multiple zones and areas. So we have to make sure that we have a proper chain of custody association, and we are trying to tackle any legal challenges based on the local rules. We have to make sure, especially because of the high reliance on the cloud provider, that all our security ownerships are defined clearly, because without this, our incident response plan will become chaotic. We got lots of moving items, so asset discovery and inventory is really important for you to be able to tackle any incident. You have to make sure you try to be as spot on as possible with that. We also have, because of how cloud works, an increased attack surface, and shadow IT also causing massive issues in cloud, and there are also unique attacks compared to what there is against on-prem, against the cloud resources, which requires a different mindset of defending against these. I wanted to cover attack surface management and shadow IT in a bit more depth, because in my personal opinion, I think this is really important in cloud. It's already difficult to defend against what we know about and what we have access to, but it's even more difficult to defend against something we don't know about, because people are trying to spin up applications, services without the control and knowledge of the security and IT department. This used to be an issue in on-prem as well, when people used to install their local internet breakouts in a local office just to avoid any proxies, but it's especially bigger within cloud. It can also be an issue because these people can sometimes spin up these instances, not even within our company assets and organizations, but they will just create their own org or project using their own bank cards or corporate cards, essentially making it almost impossible for us to know where these are. This doesn't stop having data in the cloud, which are corporate data, which we need to defend, and this causing massive blind spots for us to tackle, at least also causing you compliance problems because you have no control over what's happening. Luckily, there's ways how to tackle this. It is really important for you to map your applications into all the resources and services you have, so you understand how your application works, like what containers involved, what serverless functions involved, so when there is an incident, you know where to go and tackle the incident accordingly. As defined, having a robust asset collection pipeline is necessary. Without this, you can't tackle incidents in cloud efficiently because you don't know what you are protecting. And also, as mentioned, where you got customers or people, employees, spinning up instances outside your control, for you to identify those, you can have attack surface management tools, which essentially scan the web for any potential company assets, domains, IP ranges, which could associate with your network, giving you full visibility on those. Some of the challenges and how cloud works is also different versus on-prem. In the on-prem world, the initial foothold normally happens through a phishing email or delivering an exploit or payload to the machine, or trying to attack and expose the application. And on-prem, you don't have many of these because most of your applications are behind DMZ. You only expose what you need to. In cloud, this is different. Most of your resources are out there, accessible, and the way how your applications and resources work are different too. Essentially here, you don't have your own old siloed way when you have a different server for database, web server, but you're trying to work on microservices, you're trying to define serverless functions, and you're trying to run these workloads on containers or virtual machines. Because of how this works, it's also the attacks against them will be significantly different as well. One of the biggest issues I find in cloud response is misconfigurations, which essentially misconfigured firewall configurations, permission issues on buckets or object storage, essentially exposing your data and causing data exploit issues. Attackers also trying to attack the serverless functions by code injection. They're trying to abuse CI/CD pipelines by trying to look for weaknesses in the workflow, trying to essentially inject and change the templates used for your infrastructure as service spin-ups. So they're trying to essentially compromise your pipeline itself. It's a massive issue about misusing resources in cloud, which is mostly attached to crypto mining, which is a massive issue in cloud because attackers and sometimes employees will spin up instances trying to get some financial gain out of your infrastructure, which is not great. There's also threats against the containers we use. Can be anything from trying to introduce a malicious image for the container or trying to escape container applications. And again, abusing authentications and cookies can also an issue. Most authentication and session management in cloud is happening by cookies. If the attacker can compromise your session cookie, essentially they can gain access to most of your infrastructure and data. Yes, so as you can see, the amount of attacks and things are not the greatest. I slowly try to feel why AI thought so gloomy and dark about Cloudpocalypse. But instead of trying to stay here and be caught in the storm, let's look at the way how we can tackle this and how we can make sure that we can be up for the challenge of tackling incident response in cloud. We start off by building a cloud-aware incident response plan. To start with, it's really important that we start by defining our cloud-specific risk and define a plan for each of these. These risks can be anything from data exfiltration, to malware, to ransomware, to authentication attacks, data exposure. The list is massive. You have to understand, you have to look at your environment, and you have to define these. Because of the reliance on the shared responsibility model, it's also recommended to define a framework how you can communicate and engage with your cloud providers. And when you do, you define and assign clear roles and responsibilities within your IR plan, so you know which teams are accounted for each action, not just internally, but on the cloud provider side as well. It's also beneficial to define these escalation paths, and where possible, I also recommend trying to integrate with some of the security procedures from the cloud provider side. Because of the extended landscape, it's also important that your plan is considering local laws and privacy issues, especially when you have to think about different rules on how you have to expose your incident to the public, and also how you can collect data in different regions based on where you are. There are plenty of frameworks and data out on the internet from NIST to MITRE about how you can tackle incident response. What I did find, there's not many of these considering cloud as a specific area, apart from the one which I recommend in this slide. From the Cloud Security Alliance, there's a cloud incident response framework, which can be a really good point to start or a good place to go when you are trying to adopt your incident response plan from on-prem into the cloud, or when you're trying to engage on your journey. The document is free. You can download a copy as long as you register for a free account with the Alliance. We also have lots of tools which can handle some of these incidents in cloud. And we all know how the security industry love acronyms, and cloud is taking their fair share of these acronyms to include. There's a huge list here. I will go through each of these. I also set myself a challenge before this presentation. If I will be able to recall all these acronyms without any mistakes, I will treat myself for a Denver Nuggets basketball shirt later. The first one is cloud security posture management, which is essentially looking at your management plane and help you identify misconfigurations and vulnerabilities in your resources deployed in your cloud environment. It will help you find insecure firewall configurations, insecure API keys or API keys not rotated, or anything which could relate to any configuration which could cause you an issue with your posture. You can also define posture management rules, like if you operate within the European Union and you only want to deploy resources within the EU, you can define policies that the system will trigger and can generate a finding when somebody spins up an instance outside the allowed region, or if you have certain policies that certain workloads must be deployed with a certain level of security. If somebody is trying to deploy a configuration which is not compliant, it will be flagged, and it will also monitor for configuration drift if somebody changes something which is not compliant anymore with your systems. This is great for the management plane, but it's not really help you giving visibility inside your actual workload. For that, we got a cloud workload protection platform, which essentially does what it says on the tin. It gives visibility inside your workloads for potential threats, file integrity monitoring, any malwares or such running inside your machines is trying to find and flag it to you and essentially provide a runtime protection to your cloud workloads. We got cloud detection and response, which is essentially look for detecting threats and activities within your cloud logs at source, or it's also look for detecting certain threats potentially affecting your containers or virtual machines. It will flag these malicious activities, essentially helping you and enabling your incident response and forensics activities. We also got cloud infrastructure entitlement management, which is used for managing identities and privileges, looking for excessive privileges on accounts, essentially trying to help you identify if you have any applications which may have privileges which are not required. These are not a replacement for IDMs, but more to complement these. So if you have any need for these in your environment, it's certainly good to look into these. There's plenty of free and commercial solutions out there on the market. The only downside that most companies on average already have 15 plus devices and solutions in their security stack. The last thing we want is introduce 3, 4, 5 more. Only if there would be one solution which covers all of this in one place, which I think we all see where I'm going with this, especially because I had 5 acronyms and I only covered 4 so far. And which is the last one, which is the Cloud Native Application Protection Platform. CNAP essentially combines all of these technologies in one place, and it helps you to give you one central location where you can start managing your threats against your traditional and cloud-based workloads. It helps you with threat detection from the containers for the virtual machines. It enables you to contextualize threats and also correlate against threat intelligence data within your cloud platform, even before you're hitting your SIEM, so essentially enabling you to define an event-driven workflow for your incident response even before it's hitting the SIEM, which helps you detect some of these incidents faster with the additional tools included. It's also helps you remediate against vulnerabilities and misconfigurations in your resources. And if you ever try to tackle cloud findings, you will see the list can be a bit daunting initially. You will log into the platform, you're going to have thousands of initial exposure findings. These tools are also great trying to find matches between where you got 2 different resource or finding which could be innocent on its own, but together they can combine into a toxic combination, which would give you a need to attach those and you tackle those incidents faster. So essentially giving away how you can prioritize what you investigate first and concentrate on what matters most. You also got the option to integrate with third-party tools like SIEM, SOAR, workflow, ticketing systems, or notification channels, and most of these applications will support multi-cloud. Having this tool is great. Having these incidents to identify is amazing, but it's not a replacement for some old-fashioned logs. Cloud logging is really important. There's a saying in network security, PCAP or it didn't happen, which essentially say, unless you can show me the packet capture of the activity, I won't believe the event actually happened. I believe logs are equally as important. So in my mind, unless you got the logs to prove it, the activity never happened. But what logs do we need? There are lots of different types of logs in cloud. We got logs for the management plane, which contains all the audit type activity you perform on your resources. Data plane logs, which is logs coming from the applications. Flow logs coming from the network connectivity between your applications and the outside. User logs coming out of the application too, on what the user is actually doing inside your application. Access to this data sometimes can be difficult, as discussed, because of the shared model, and also routing these logs efficiently and cost-effectively can be a challenge sometimes, especially down to the volume of the data you have within Cloud Logs, because when you enable this first, the amount of logs is just massive. For that reason, I recommend trying to investigate the event-driven automation, as I said on the slide before, which can essentially try to look for findings detected even before your data is hitting a centralized platform. We covered the preparations, we covered getting the right tools, we covered how to identify the incidents. So let's get on phase 3 of the incident response framework from NIST, which is about containment, eradication, and recovery. When you identify your incident, it's really important you have a right containment plan in place to contain the attack. For this to be efficient, you have to make sure that your mapping of applications or services are defined properly, as we discussed earlier. Without this, effective containment will be almost impossible. And within your plan, try to list all the actions required to take based on each of the incident types. The main step you have to achieve here is to stop any further activity. You have to make sure, because the attacker, when they reach your network, the first thing they will try to do, they will try to find additional backdoors, they try to move laterally, essentially trying to give more and more exposure for themselves. Even when you contain the incident, it's important to monitor and look for any potential system re-entry. As part of this, you may find that the attacker may take a different path this time, helping you identify potential additional attack exposure path into your network. Once you contain, it's important don't delete the resources if possible, because for effective post-mortem and for effective legal requirements, it will be important to have access to these resources. And again, try to choose your containment strategy based on your acceptable risk and based on what's right for each of the incident type defined at the beginning. Once the containment's happened, the next important step is eradication, where you need to minimize your loss, theft, and service disruption. You have to restore your application or service into an operational level. This can require restoring disks, wiping disks, restoring applications from backups, changing API keys, changing permissions, whatever is required to get the machine back into operational level. And once you get there, it's important that you get to the recovery phase, where essentially you are restoring the application and service to the point where it was before the incident started, or into a better stage, which can again include changing passwords and keys, restoring files, applying patches, rebuilding any workloads where possible. The last step of this phase is the post-event activity, which again, this is really similar to what you would do on your on-prem incident response, but I still find it important to mention because it's still part of cloud incident response too, and we have to make sure that we do a proper post-event analysis of what's happened during the incident. Security is an ever-evolving cycle, so any place we can find to improve the process is something we should look into. Best thing to do is ask the usual question, what could have been done better, not just by us, but potentially by the cloud service provider as well, to establish and evaluate anything which we could have done differently, and then use the feedback loop to potentially implement any of these into our incident response plan going forward. It's important for the process as well to be quantifiable. So it's important to define measurable metrics from mean time to detection, mean time to eradication, and so on and so on. In my mind, it's important to conduct these post-incident reviews after every major incident if possible. It's also recommended to try to analyze the attack vectors and the root cases within the incident and see if you can potentially update your resources, update your configurations to avoid such incidents happening in the future. We covered most of this, and SIEM SOAR is something which lots of people defined as almost dead for the past few years, and it's been around for decades, and I think it's still an important piece of the security puzzle. And without this, I don't think we could have efficient incident response, given it's on-prem or cloud. So it is a good place to try to centralize all your findings and data in one location between your cloud and on-prem. A tool like this can also help you contextualize and enrich data. Because again, it's great to see that we have some traffic coming from an IP address 10.10.10.10, but it's not going to be much meaningful without the available context. But if we can supply that information to the system, then our analysts will immediately know that that traffic essentially is not just a machine, but it's a desktop machine in our corporate network, and the machine belongs to one of our IT support analysts, Elliot Alderson. We can also supply threat intelligence data, and we can correlate with these. So we can also see that if the machine used to access some destinations, that destination is essentially associated with a threat actor, let's say APT41, was part of a phishing campaign. So now we know that we're possibly going to have a chat with Elliot to discuss that the website he used to book those basketball tickets possibly was a phishing site, and now he should change his user details and possibly speak with his bank. We can also correlate this with activities happening after. So again, we can match activities which are happening individually from each other. So if we now see that Elliot's machine is now going to a command and control destination, or if we see that his AWS account is now spinning up compute instances trying to mine for cryptocurrency, then we possibly know that these attacks are related, so we can handle this much efficiently and closely within our incident response plan. We can also use dashboards to visualize data, which can help us identify patterns in data which may not be visible just by looking at the raw logs. Having a tool like this will help you maintain your compliance and also help you be alerting in real time, because if something serious happens, you don't want to wait for your analyst to run a report on Monday morning. You want to be informed immediately. Most SIEMs nowadays are coming with SOAR functions, and it's something I also recommend to integrate with, because lots of the actions and alerts which come from a SIEM, the actions the analyst would do after is repeatable, can be automated. So it's always nice to be able to automate as much as possible to help free up time for the analyst to be able to concentrate on what is really matters. Since we covered SIEM SOAR, just wanted to touch on some of my favorite use cases I like looking into when I'm working with different customers, depending on their different part of their journey within cloud and incident response. The first use case I always recommend is the cloud misconfigurations. Most of the cloud misconfigurations, the remediation actions and the steps you need to do to investigate are the same, easily repeatable. So instead of having it done manually each time, I always recommend to start trying to build a couple of SOAR playbooks, which can help your analysts to only look at the outcome of the alert, not to having to go through each steps manually and do everything manually. We covered shadow IT and the attack surface management issue at the beginning as well. I always recommend trying to build a couple of alerts and a couple of playbooks and workflows on running through these, because whenever the incident happens, analysts would normally log into different system, enrich data, then make a choice based on the data provided if they want to remove the instances or resources. We can automate these. We can automate the enrichment part, and we can also automate the response part. So if the analysts decide that that resource should be deleted, they don't need to log into the cloud platform. They can just initiate the playbook to go through the steps required to remove those assets. Same goes for cryptojacking and crypto mining. It's something I do recommend looking at where possible, because this is a massive issue for cost and potential exposure. So being able to build rules and playbooks to automate some of this can enable us to detect and manage our incident risks significantly faster. The last one is not really a security issue, but it helps highlighting how tools like this can be used for more than just security, especially in cloud where cost optimization is really important. It's always recommended to do some reports, dashboards based on the resource utilization, cloud metrics, and potentially define some notification rules or reports for our teams to flag if there are some activity happening or if the cost is escalating faster than we would like. Not to mention, sometimes the cost escalation could mean a crypto mining attack as well. There's one important step we still have to cover. We could have the best possible cloud incident response plan, or at least we think we do, but without testing it, we can't really be certain. And testing this in the middle of a real attack is possibly not the best option and idea. So I also recommend to try to come up with a testing method against your incident response plan. Again, this will be fairly similar as what you would do on-prem, so there's not much differentiation here. Maybe just the tools you use will be a bit different, but you can do your tabletop exercises. You can run red, purple teaming activities. You can replay old attacks from your environment, or if you have access to, you can do attack simulation tools or security validation tools to replay certain attacks and see how your teams and how your service provider responds for the incident. Try to identify any process and skill gaps, and if you find any, then update your incident response plans accordingly. Activities like this could also be done within a cloud sandbox, so it's not affecting your production environment that much, but a cloud sandbox can also be used for training your analysts and giving them a platform where they can play around and expose themselves to gather some more experience so they don't play with your production platform. I used AI at the beginning of this presentation to generate the image, but I also believe we should cover a couple of words about how AI can augment and help your cloud incident response, as I believe it's not just a buzzword, but it's here to stay, and it's only going to get more importance over the coming weeks, months, days. It essentially, I believe, will transform our approach, how we handle security, and how our analysts can access data. There are lots of information out there, from security blogs, playbooks, malware information, threat intelligence, production documentation, specialized data sets. It is good if you can have access to a model which is trained on this data, or if you can train your own model where you can input your own data as well with your past incidents, your internal documentation. So when your analyst investigates an incident, they get access to a tool which can essentially help their day-to-day activity. Currently, AI, what I would call as in a assisted mode. What I mean by this, it's used to enhance and boost our productivity. It can help us to do searches in the language models for a common security question to find information fast. It can be used to use natural language to generate a SIEM query, because we may not know how all different SIEM platforms define their queries, and we don't need to anymore almost. Can help you automatically create playbooks and also use natural language to create SIEM rules as well, enabling your analysts and your engineering to free up time and concentrate on the more advanced things. As the next phase in the evolution for this will be what I call a semi-autonomous, when AI will be essentially in charge for performing most of the initial part of the incident response to a high quality and escalate or involve manual requirements only when it gets to a point where it requires to have a human interaction. Before we get there, trust needs to be established because there's still lots of times when our current situations are giving a response which may not be the response we're after. It's great that we have access to this, but attacks on the AI are also in increase. Threat actors are trying to poison data sets. They're trying to input adversarial inputs into the language models and trying to compromise the source. And attacks with AI are also an increase. The threat actors using these tools to generate some of the initial scripts, malware to help them in their exposure going forward. So it's the same challenge. We're still fighting the good and bad battle. Tools are changing, but we still have to make sure that we give the best chance possible for us. Before I wrap up, just wanted to cover some of the best practices or the highlights of this session, which I recommend to go away with as high level. Make sure you understand the shared responsibility model between you and your supplier, and make sure that you define these frameworks between yourself. When you define your incident response plan, that you define with the approach that you are including the service provider too. I also recommend to monitor the cloud supplier for any outages or security compromises, so you may want to be aware of if something happens on their side. I strongly recommend not to ignore shadow IT, because this can present lots of different issues for the future. And I also recommend, as always, to foster a culture of learning and improvement within your teams, so your employees can understand why they should not bring up resources outside your knowledge, and they should also understand why security in cloud is important. Develop these partnerships with your developers and your security teams, as in cloud, lots of time instances are being spinned up by the developers themselves, and make sure they're aware that security is not just an add-on, but essentially is baked in the process, it's part of it. Have the right tools, which could be any of the cloud acronyms or the tools associated, SIEM SOAR, any workflow. And as I said, show me the logs, or I don't believe it's happened. Make sure you got the right logs in place. It's great to be able to handle the incidents and stop them. It's even better if the incidents won't happen in the first place. So if possible, ensure guardrails are in place so you avoid the incidents happening in the first place. Have a centralized platform like SIEM, where you can automate your activities and embrace the power of automation. It will help the happiness of your analyst and also be able to work on the important tasks. As important, regularly test and update your incident response plan. And I do recommend to look into the Cloud Incident Response Framework, which we covered from the Cloud Security Alliance at the beginning. When you work about incidents, always try to think with the attacker's mindset, but your actions should reflect of the mindset of a defending champion. And I believe it's here to stay, and it will be a big thing going forward, so I recommend to try to adopt AI securely and responsibly. We started off the session by seeing how the storm can cloud our data and infrastructure, but hopefully after these sessions, with the tools and knowledge acquired, we can see the lights breaking through the clouds, and we will be able to handle these incidents with a much better efficiency in the future. You got this. You have the power to conquer cloud incidents. And just a disclaimer, the picture is also AI created at the end of this presentation. If you do have any questions, I'm happy to try to answer. We have a couple of minutes left. Otherwise, I'm happy to answer any questions after the session too, or tomorrow morning at 11, there's a birds of a feather discussion at the expo floor covering a similar subject. So if you want to join me for that one, you're welcome to come, have a chat, have a coffee, and discuss any of these activities in any further. If there's no more questions, then I do appreciate and thank you for attention and time, and I will let you enjoy the rest of the sessions.